In this section, we'll cover the fundamentals of network address translation, also known as NAT. NAT, defined in RFC 1631, operates in Layer 3 forwarding devices to provide address simplification and conservation. The most common use of NAT is to connect networks using private RFC 1918 network addresses to the public Internet. NAT translates the private addresses that are used in the internal network into public addresses that can be routed across the Internet. As part of this functionality, you can configure NAT to use only one address for the entire network to the outside world. Using only one address effectively hides the internal network, thus providing additional security. Multiple devices can be configured to perform NAT services. Although firewalls are the most common, routers and Layer 3 switches are also capable of deploying this service. Cisco defines the following list of NAT terms. The inside local address is the IPv4 address that's assigned to the host on the inside network. The inside local host is likely to be one that falls within the RFC 1918 reserved private IPv4 address space. The inside global address is a globally routable IPv4 address that represents one or more inside local IPv4 addresses to the outside world. The outside local address is the IPv4 address of an outside host as it appears on the inside network. Not necessarily a public address, the outside local address is allocated from a writable address space. And finally, the outside global address is the IPv4 address that's assigned to a host on the outside network by the host owner. The outside global address is allocated from a global routable address or network space. In this example, the two inside hosts are each allocated a local IP address. 10.0.0.1 is assigned 209.165.201.10, whereas any outbound traffic from 10.0.0.2 will be assigned to 209.165.201.11. The inside local address is likely to be one that falls within the RFC 1918 reserved private IPv4 address space. That reserved address space consists of 10.0.0.0/8, 172.16.0.0/12, and 192.168.0.0/16. These addresses are not routable on the Internet. This figure illustrates an ASA that's translating the source address as the packet is forwarded from the inside to the outside and reversing that translation on the reply that returns. The steps are taken are as follows. Host 10.10.10.11 sends a packet to host B. The ASA receives the packet and checks its NAT table. It finds an entry to translate 10.10.10.11 to 203.0.113.2. If there was no entry in the table, the ASA would check the NAT rules to see if there was a rule specifying a dynamic translation. If there was such a rule, a new entry would be created. The ASA replaces the inside local address of 10.10.10.11 with the inside global address of 203.0.113.2 and forwards the packet. Host B receives the packet with 203.0.113.2 as the source address. When host B replies, it specifies 203.0.113.2 as the destination address. When the ASA receives the reply packet and checks its table, it finds the entry that's associated with the inside global IPv4 address of 203.0.113.2. The ASA replaces the inside global address of 203.0.113.2 with the inside local address of 10.10.10.11 and forwards the packet. One common variant of NAT is dynamic port address translation, also known as PAT. PAT is sometimes referred to as NAT overload or as high NAT. PAT allows you to translate multiple internal addresses into a few external addresses or even a single external address, essentially allowing the internal addresses to share one external address. PAT uses unique source ports on the inside global IPv4 address to distinguish between translations. Because the port number is encoded into 16 bits, the total number of internal addresses that NAT can translate into one external address is theoretically as many as 65,536. Some firewalls will also use a destination IP address and port numbers to distinguish between translations. In this case, the same source port number can be used multiple times, increasing the scalability even further. In either case, PAT allows for highly efficient use of the address space for outbound sessions. NAT requirements will vary from situation to situation. The Cisco ASA supports a variety of NAT deployment modes depending on the requirements. Here you can see 5 unique deployments of NAT. Static NAT maps an unregistered IPv4 address to a registered IPv4 address. One-to-one static NAT is particularly useful when a device must be accessible from the outside of the network. For example, static NAT is used when a DMZ server needs to be continuously reachable by the same predictable translated address. Dynamic NAT maps an unregistered IPv4 address to a registered IPv4 address from a pool of registered IPv4 addresses. This is used for outbound client connections when you have fewer outside global IP addresses than the inside local host. When describing static PAT, it's best to imagine a network that has one single public IP address. This IP address must be used by the firewall that connects the network to the internet and must also be used as a PAT address for all outbound connections. If this network must also support a DMZ server, then static PAT can be used. For example, TCP port 80 may be reserved for PAT translations to the HTTP service on the DMZ server. Static PAT is sometimes called port forwarding. Finally, policy NAT uses extended criteria such as source address, destination address, and transport layer ports to specify the translation. For example, traffic that's destined for a particular network may be translated to a specific address reusing PAT, while traffic elsewhere is translated using a dynamic NAT pool. For further example on NAT and the configuration options, refer to cisco.com and the ASA NAT configuration examples.